A particular station of All India Radio New Delhi broadcasts on a frequency of 1368 kHz. The wavelength of the electromagnetic radiation emitted by the transmitter is, and they are given what is the speed of light, the formula, and they have asked us to find out the wavelength of electromagnetic radiation. So the energy of electromagnetic radiation formula is hc by lambda, which is equal to h gamma. So we all know c by lambda is equal to gamma. Therefore, lambda is equal to c by gamma. So lambda is equal to 3 into 10 power 8, that is the speed of light, by 1368, that is the frequency, into 10 power 3. When the calculation is being done, the answer will be 219.3 meter, which is nothing but the option 4. So the wavelength of the electromagnetic radiation emitted by the transmitter is around 219.3 meter. The right option for the number of tetrahedral and octahedral voids in hexagonal primitive unit. Tetrahedral and octahedral voids in hexagonal primitive unit. So basically in a hexagonal we have 6 atoms. Okay, and the number of octahedral and tetrahedral voids in an enclosed packed atom is, for tetrahedral it is around 2n, and for octahedral it is around n. So when we substitute this into this, we can say 2 into 6, which is equal to around 12 points, and here around 6. So the answer is option 3. The following solutions were prepared by dissolving 10 gram of glucose into 250 ml of water, 10 gram of urea into 250 ml of water, and 10 gram of sucrose into 250 ml of water. The right option for the decreasing order of osmotic pressure of these solution is, so basically the osmotic pressure, that is denoted by pi, is equal to ICRT. So with increase in, we know that with increase in molar concentration of the solution, osmotic pressure also increases. So since the weight of all the solutes and its solution volumes are equal, because it is 10 gram of glucose, 10 gram of sucrose, and 10 gram of urea in 250 ml of water in all the 3 cases, the higher will be the molar mass of solute, and smaller will be the molar concentration, and smaller will be the osmotic pressure. So what they are trying to say is the weight of the solute and its solution. Solute is the glucose, urea. The solutes are glucose, urea, sucrose, and the solution for all the 3 is water. All the 3, this thing and this thing, are equal in amounts. Therefore higher molar mass of solute, lower molar concentration, thereby lower osmotic pressure. So the order decreases by sucrose is greater than glucose, is greater than urea. So the correct order of osmotic pressure of the solution is P3 lesser than P1 lesser than P2. Which can also be written as this. TCl5 is trigonal bipyramidal. SF6 is octahedral. BRF5 is square pyramidal, and BF3 is trigonal planar. Option is 4. Ethylene diamine tetraacetate is ion is what kind of ligand is the question. So basically this EDTA, ethylene diamine tetraacetate, it is a hexadentate ligand. What ligand? Hexadentated ligand, and it has 4 donor oxygen atoms and 2 donor dinitrogen atoms. And this is the structure of ethylene diamine tetraacetate. So the option is fourth one. Extra dentate ligand with 4 donor oxygen atoms and 2 nitrogen donor atoms. So the next question is, the right option for the statement Tyndall effect is exhibited by is. So what kind of solution causes Tyndall effect? That is the question. And the options are glucose solution, starch solution, sodium chloride solution and urea solution. So basically this Tyndall effect can be exhibited only by a colloidal solution. What kind of solution? It can be exhibited only by a colloidal solution. In this given options, urea, sodium chloride and glucose, all these three, 1, 2, 3, those that I have marked, all these three are true solutions. Since they are true solution, they cannot exhibit Tyndall effect, whereas the starch solution is a colloidal solution, thereby it causes Tyndall effect. So the option is 2.
The major product formed in dehydroalgenation reaction of 2-bromopentane is pent-2-ene. This product formation is based on. So with what rule does the reaction of 2-bromopentane results in pent-2-ene? That is the question. And the options are Hund's rule, Hofmann's rule, Huckel's rule and Zaitsev rule.
Basically, the major product that is formed in this dehydroalgenation reaction to form pent-2-ene from 2-bromopentane is because of Zaitsev's rule. That is option 4. And what they are saying is, in dehydroalgenation reactions, the preferred product is that alkene, which has greater number of alkyl groups attached to the doubly bonded carbon atoms. Alkene, which has greater number of alkyl groups which doubly bonded carbon atoms. Dihedral angle of least stable conformer of ethane is at what degrees? Basically, ethane has two conformers. One is eclipsed and other one is eclipsed conformer. It is least stable, whereas the staggered conformer is most stable. Therefore, in eclipsed conformer, the dihedral angle is 0 degree, whereas here it is 60 degree. Therefore, the dihedral angle of least stable conformer of ethane is eclipsed and it is of 0 degree. That is option 3. Question is, the major product of the following chemical reaction is. This is what is the answer. If you need a detailed mechanism of the reaction, please do post in the comments. I'll let you know through shorts. What is the correct structure of 2,6-dimethyl-dec-4-ene is? This is the structure of 2,6-dimethyl-dec-4-ene. Sorry for the odd forms. Next is, zirconium and hafnium have similar atomic and ionic radii because of what of the following? Either due to diagonal relationship or having similar chemical properties or lanthanide co-interaction or belonging to the same. Basically, cumulative effect of lanthanoid series. It's called as lanthanoid contraction. Why? Because the radii of the members of the third transition series is similar. The radii of members of third transition series similar to second transition series. So, zirconium, as the question says, zirconium and hafnium have similar atomic and ionic radii. So the answer is lanthanoid contraction is the answer. Second point. Two statements are given and we have to find out which statement is true or false. Either both are true, both are false, or either one is true or false. The first statement is aspirin and paracetamol belong to the class of narcotic analgesics, and the second statement is morphine and heroin are non-narcotic analgesics. So in the light of the above statements, choose the correct answer from the options given below. Basically, it is the ulta of the one other, that is aspirin and paracetamol, those belong to the class of non-narcotic analgesics because these are medications basically, whereas morphine and heroin belong to the class of narcotic analgesics. So both statement 1 and 2 are false. Option is, which one of the following methods can be used to obtain highly pure metal which is liquid at room temperature, either through chromatography or through distillation or through zone refining or electrolysis? The answer is distillation method. Basically, this method is used for purification of metals. Mainly metals that have low boiling point. Example, hydrogen, zinc, etc. The question is compounds which show metamerism is. So basically, compounds that are ethers show metamerism, and in this 4 option, the compound that shows metamerism is C4H10O, and this can be written as of the following reaction is a metal displacement reaction. Choose the right one. So they have given 4 options, and we have to find out which of these reactions are of metal displacement reaction. So here the reaction number 1 and 2 are example of displacement reactions. 1 and 2 are example of displacement reaction, whereas 3 and 4 are example of decomposition reaction. Out of 1 and 2, 1 is the one which corresponds to metal displacement reaction. So the option is 1.